Greetings to you again. Let's continue with our lessons of photovoltaic energy. Your instructor is still Dr. Kateko Mabundra, who is a professional engineering technologist registered with EXA. In this section, we'll make sure that at the end of it, you are able to describe the electronics or electrical components in terms of their uses, application, and necessity. You must be able to identify or present basic electrical and electronics symbols which associate with components that we are going to describe. You must be able to sketch a circuit diagram to show how those components are interconnected. They can be parallel alongside one another, and they may be in series where one go after the other. You must be able to interpret sketched schematic and translate them to working physical circuits. As our introduction here, documentation is necessary in electrical engineering. Whatever you come up with that you have designed or created, it must be accompanied by documents. You have purchased an electronic product before, cell phones. In the box, you find that there is a manual. That is documentation. That manual which you have as a user, it's different to what the supplier have. The supplier might even have a schematic diagram that aid them on repairs. But in your case, you have it for the purpose of understanding how to operate your device. Every electronic component or electrical engineering is associated with a symbol for it. We're going to see as we continue what symbol is used for which component. And they have to be named. Just like you in class, for an instructor to differentiate between one student to the other, you have student numbers as a form of naming in class. Now, here with the component, we have what's called capacitor, which can be polarized or non-polarized. Non-polarized capacitor is that one. Polarized capacitor, you see it has got a plus sign to show you where the positive is. And beside being polarized or non-polarized, they differ in brands. This is called electrolytic. This, it's more like ceramic. Now, what does the capacitor do? It stores a voltage temporarily for a short time and release that voltage to a circuit when it's needed. Short time is a very small fraction of a second because voltage signals change at the blink of an eye. In fact, at the blink of an eye, you can have as fast as millions and millions of changes. So in some instances where you need to stabilize your signal, you use a capacitor. The next one is a diode that falls under the class semiconductor. You know a conductor conducts electricity. You know a non-conductor doesn't conduct electricity. If we say semi, something between conductor and non-conductor, it conducts when certain conditions are met and not conduct if they are not met. For instance, this one will only conduct in such whenever the top part, which we call the anode, is connected to positive and the bottom part is connected to negative. So then you see one thing. If you look at positive and negative, the current electron flow will start from negative to positive. So the arrow opposes the electron flow. And the opposite current to electron flow is convectional current. Now, there is another special diode that emits light whenever it conducts. We use it for indicators. Not indicator in your car, of course. If you look at your TV, if it's plugged but not powered on, quite often you will see somewhere there is a red light. That's where they use LED to indicate that your system is plugged, ready to be used. Well, before we look at this one, let's go to the last one there. That is called a transistor. Having understand the diode is a component which has got two poles. The other one you apply positive P, and the other one you apply negative N. So if you're gonna take two diodes, connect it together like that, you have one N in the middle and the P's at the output, and input. So that's a P and P, positive, negative, positive. That will be N and P and P transistor. But if you have them the other way around, like that, you will have N, P between another N and one N. So it's like having one structure of a diode that is sitting between two similar structures. What is the role of a transistor? The transistor, it amplifies signals. So you will find that instead of calling PNP and PN, they use these terminologies, which is a base where you apply small current and you have an emitter of electrons at the output. These emit electrons that go to some area where they are collected. So the base will bring small current to control a huge current that occurs between the collector and the emitter. Hence we say it's amplify. So you can like grow this small base current slowly, but then you have the output changing slowly but in a larger magnitude. You are amplifying. Or you have the base between two instances, high and low. When you apply low, it's off. When you apply high, extremely high at the high voltage. Maybe let's say you use 1 volt to switch on 20 volts. Hence the term switching comes in there. Now, we can go back to that component we were in. If you look at that component, it's like a LED, which is coupled to a transistor. This transistor at the base, which I already mentioned, it receives light, and that light controls the emitter collector current. So, but where will the light come from? It comes from the LED. What is the idea of this? Is to isolate circuit. If you have got a circuit which is full of hazard, you don't want your component to interact with it. Rather, they interact with the light you produced. You use that. The next one is a variable resistor, which looks like that, and another one which look like that. A variable resistor, if you want to know where to find it, the volume control actually varies the resistor. Let's say the manual knob, this which you wind on front of a device, you wind that way, and then the volume go out, up, you wind that way, the volume go down. That rotate one of those things, variable resistor. There is a circuit symbol for it, and sometimes you may not use the knob, you use a screwdriver, insert it in, twist it, then you change the value of what has to be changed. Then we have again what's so called a relay. A relay can be used for switching like transistors, but now it's mechanical. It arises from the phenomena that whenever you apply voltage to the coil, it creates electromagnets. Now, let's say we have a switch here. There's a switch. There's our switch to switch on off the coil. Now, if we press the switch, we create magnet. Suppose we have one plate there and another one there. This one connected to the spring and connected to positive of a certain battery. If we push this knob down, switch on, this create a magnet, this which will move this towards that, they create contact. Then this positive will be taken to a destination. If we release the switch, the spring will pull back this and the connection will exist no more. Then you switched off. That's how a relay operates. There is another one which is called stepper motor. Just like a motor which you will use to rotate our fans, rotate our blenders, rotate our hair dryers. But this is the controlled digitally. You send a pattern to rotate it clockwise, another pattern to rotate it, drive it anti-clockwise, and to increase the speed and so forth. And we have a switch, a switch at the wall near the frame of your door is where you switch on lights. That button which you press down, press up, or rather a device that you pressed up. When you press the top part is off, when you press the bottom part is on, the light is a switch. This one we already discussed, transistor. Now we come to resistor. Resistors, you have used it. Remember Ohm's law, where we say V is at the top, at the bottom we have I and R. So, but that limits that one, the current. That's an exercise here. Now you'll have resistors which has got a band of colors. The last one quite often is gold or silver. Sometimes they use brown. Though that is a tolerance of the value which you're gonna find here. We still have gonna discuss that. So if it's gold, it's 5%, silver 10%, brown 2%. or 1. You will have to verify that. Now, if the first band here is the first digit, the second band is the second digit, the third is a multiplier. So if you got a certain value with 1 and 2, you multiply it by 10 raised to the number represented here. Now, we say these colors represent numbers. Let's explore this clearly. If you look at where there's brown, the first digit is 1. So brown represents 1. And if you look at the black as a second digit, where there's black is 0. So black is 0. So if we have to write something, 0 for black, 1 for brown. Where do you see 2? On red. See it's 2. 2 for red. And then 4 for yellow. And so forth. So now, let's put this into practice and see if we'll be able to tell the value of a certain component. We're going to pick up this one there. It starts with red. Red is what? We said is 2. You don't have to memorize. You can go and reference check, have a chart for yourself where you copy it. And then the second one being brown. Brown, we said brown is what? Is 1. If it's brown, right? Or it looks black, it says black, so black is 0. And the multiplier times 10 to raise, and then we have got another black, which is 0. So any number to the power 0 is 1. 20 times 1 is 20 ohm. And the last color being gold, it means it's got 5%. So it can vary around 20 by 5%. What is 5% of 20? 5% of 20, it should be 5 over 100, which is 1 over 5. It should be like around 4. You can calculate there. Right. Now, let's look at the circuit. We said we must be able to sketch circuit. This question, they said design a LED circuit which will be having 20 milliamps as the current. Milli is 1 over 1,000. So it's 20 divided by 1,000 amps. So they carry on and say existing voltage across the LED is 2 volts. That's it. You can't do anything about it. That's how it was made, to have 2 volts across it. But your supply, you chose that to be a 12 volt. Now, you can't take an LED and connect directly to the battery. It's gonna blow. You need to limit its current. That's the role of a resistor. Now, we limit the current through the LED by a resistor. We need to make sure that this doesn't stop every current or limit enough. So we'll have to find the voltage across it. The voltage is gonna be 12 minus 2 is the remaining, which is 10. To get resistance from voltage, we divide by current. It was supposed to be 20 milliamps, but we say 20 milliamps is that's what it takes. So we reduce it, we multiply by 0.8, we make it 80% of it. Then we divide by 16. Then our answer will be that one shown there, 625. Transistors, we've got NPN already described and PNP. They can be used to amplify signal or used as a switch. Now, there is a terminal which we call the base there, if you remember correctly, where you apply the signal of which controls. Now, well, we've got a project here to construct a day-night switch. So you're gonna use a transistor as a switch. Google it, and then or find it from online sources and use it and do it accordingly. But then when designing a circuit, you don't just join components. Join this to that, to another component, and then you get a pillar to support it. No. This is built on a board, special board. You might have seen this board when you open an electronic device. They are normally green. On top, there are a lot of components. Sometimes at the bottom, you find something like moving, shining, silver things moving, which we call tracks. So that's where you build your circuit on printed circuit boards, PCB. Now, that is a exercise. If you're still testing, you're gonna have to solder, remove solder. That's gonna waste your time. So there are temporal boards which you can use. They call breadboard, where you just plug in components, plug in, take wires, plug in, and you can remove with your hand. Those are friendly. They're called breadboard. But doesn't matter whether you use a PCB or you use a breadboard, you need to build the circuits from diagram. We said you have to document your work. So you like a house which you build from plan, electric circuit are built from circuit diagram, sometimes called schematic diagrams. And in this section, they are talking about reverse engineering. It's simple working from a board back to schematic. We said you use schematic to build board. But in this sense, you take an existing board, you sketch a schematic from it. We talked about prototyping already. There is what is called fault finding, where is to observe where the problem is, to determine where your problem is. And fault finding is a way of isolating a fault and take corrective action. So if your phone doesn't switch off anymore, you take it to the repairer. They will check the battery. If the battery is okay, they say it's okay. Check your switch which used to power on if it's okay. Then check your transistor which it's used for switching if it's okay. Finally, maybe check the board if the connections are not broken. So there are many things they will have to check. What they find not working properly, that's why they replace. If it's a switch, they replace. That process is called fault finding. You don't do guesswork, try and error. You apply your mind based on what the circuit is doing. So that brings to the end of this presentation. Let's just recap a little bit to see if we really covered our objectives here. By the look of things, we are able to describe components. We learn transistors, we learn resistors. And we can present it in a schematic symbols we do, so that let's design circuit. And the circuit itself, it was series. We are able to do that. But that was connected in parallel with the battery. So we can do that. And that LED circuit, yes, having sketched it, it means you are able to interpret what is there. So this brings us to the end of a lesson, and see you as we carry on with this program. Good luck.